This word here is pronounced stoichiometry. Chemical equations, products, reactants, and phases. Solid magnesium reacts with chlorine gas to form solid magnesium chloride. One atom of solid magnesium reacts with one molecule of chlorine gas to form one formula unit of solid magnesium chloride. Blank molecules of gaseous methane reacts with blank molecules of gaseous oxygen to form blank molecules of gaseous carbon dioxide and blank molecules of gaseous water or steam. Mass percentage of elements, 13.34 grams of hydrogen, the part, divided by 75.00 grams of the compound, the whole, multiplied by 100% equals 70.78%. Okay, I had to stop there for a second. So 13.34 grams of hydrogen, the part, divided by 75.00 grams of the compound, the whole, multiplied by 100% equals 17.78% hydrogen. Let me write that down, hydrogen. Step 2, 17.78 grams of hydrogen multiplied by the quantity of 1 mole of hydrogen per 1.01 grams of hydrogen equals 17.60 moles of hydrogen. 82.22 grams of nitrogen multiplied by the quantity of 1 mole of nitrogen per 14.01 grams of nitrogen equals 5.87 moles of nitrogen. Step 3, nitrogen subscript 5.87 divided by 5.87, hydrogen subscript 17.60 divided by 5.87 equals nitrogen, hydrogen subscript 3. Steps 1 and 2, 60.00 grams of carbon times, okay, now one thing I noticed here, there's this times written here. I really don't know where that came from. I'm positive I would have never written that. So you do not write out times like that in any sort of formula. We have standardized symbols for that type of thing. So in this case, that's going to be that little dot, which means multiplied by. So we would never, ever, ever spell it out, even though that's what we say. So 60.00 grams of carbon times the quantity of 1 mole of carbon per 12.01 grams of carbon equals 5.00 moles of carbon. 1.47 grams of hydrogen multiplied by the quantity of 1 mole of hydrogen per 1.0 grams of hydrogen equals 4.43 moles of hydrogen. So I have crossed this out here because this is what was in my transcript, and you cannot include that in the actual writing. You would never ever write the word times when we have this symbol to indicate it. Okay, here 35.53 grams of oxygen multiplied by the quantity of 1 mole of oxygen per 16 grams of oxygen equals 2.22 moles of oxygen. And again, I have crossed out this times that was in my transcript, and that has to be eliminated. You have to use the symbol for the multiplication rather than spelling out times or multiplication. Okay, so here's this. Carbon subscript 5 divided by 2.22. Hydrogen subscript 4.45 divided by 2.22. Oxygen subscript 2.22 divided by 2.22 goes to carbon subscript 2.25, hydrogen subscript 2, oxygen subscript 1. Carbon subscript 5 divided by 2.22, hydrogen subscript 4.55 divided by 2.22, oxygen subscript 2.22 divided by 2.2 goes to carbon subscript 2.25, hydrogen subscript 2, oxygen subscript 1 goes to 2 1/4, carbon subscript 2 1/4, hydrogen subscript 2, oxygen subscript 1 goes to carbon subscript 9/4, hydrogen subscript 2/1, oxygen subscript 1/1. Carbon subscript 4, okay, wait a second, something's wrong here. Okay, it looks like I just had that in the wrong place. Okay, so carbon subscript 4 multiplied by 9/4, hydrogen subscript 4 multiplied by 2 over 1, oxygen subscript 4 multiplied by 1 over 1, goes to carbon subscript 36 over 4, hydrogen subscript 8 over 1, oxygen subscript 4 over 1, which reduces to carbon subscript 9, hydrogen subscript 8, oxygen subscript 4. Carbon subscript 9 multiplied by 2, hydrogen subscript 8 multiplied by 2, oxygen subscript 4 multiplied by 2 goes to carbon subscript 18, hydrogen subscript 16, oxygen subscript 8. Three moles of gaseous hydrogen reacts with 1 mole of gaseous nitrogen to form 2 moles of gaseous ammonia. 3 moles of gaseous hydrogen reacts with 1 mole of gaseous nitrogen to form 2 moles of gaseous ammonia. 3 moles of hydrogen per 1 mole of nitrogen. 3 moles of hydrogen per 2 moles of ammonia. 1 mole of nitrogen per 3 moles of hydrogen. 1 mole of nitrogen per 2 moles of ammonia. 2 moles of ammonia per 3 moles of hydrogen. 2 moles of ammonia per 1 mole of nitrogen. So here I just put H2 is the chemical hydrogen, N2 is the chemical nitrogen, and NH3 is the chemical ammonia. So in here, that's how you would refer to each of these chemical formulas. Okay, down here, 3 moles of gaseous hydrogen reacts with 1 mole of gaseous nitrogen to form 2 moles of ammonia or gaseous ammonia. Okay, so given 8.75 moles of hydrogen multiplied by 1 mole of nitrogen divided by 3 moles of hydrogen equals 2.92 moles of nitrogen. Given is, given 8.75 moles of hydrogen multiplied by 2 moles of ammonia divided by 3 moles of hydrogen equals 5.83 moles of ammonia. 3 moles of hydrogen, 3 moles of gaseous hydrogen plus 1 mole of gaseous nitrogen forms 2 moles of gaseous ammonia. Given 45.70 grams of nitrogen, 1 grams of hydrogen. Given 45.70 grams of nitrogen multiplied by 1 mole, okay, there needs to be a 2 there. Somehow that 2 got missing. Needs to be a 2 there. Times 1 mole of nitrogen divided by 28.02 grams of nitrogen equals 1.631 moles of nitrogen. Okay, these lines here have to line up. 1.631 moles of nitrogen multiplied by 3 moles of hydrogen divided by 1 mole of nitrogen equals 4.893 moles of hydrogen. Okay, again, these have to line up. 4.893 moles of hydrogen multiplied by 2.02 grams of hydrogen. Okay, this is a typo here. Should not be an N in front of that. Okay, so you got to find where that is and get rid of that because this is crossed out because it's the same down here. So 4.893 moles of hydrogen multiplied by 2.02 grams of hydrogen per 1 mole of hydrogen, that needs to be canceled out, equals 9.884 grams of hydrogen. Given 45.70 grams of nitrogen, 1 grams of ammonia. 1 mole of nitrogen is equal to 28.02 grams of nitrogen. Okay, that should probably be included there for clarity. And 1 mole of hydrogen is equal to, oh, this isn't right, 1 mole of ammonia. Okay, so again, you're going to have to find this, and this needs to be changed. This is what it should look like. 1 mole of nitrogen is 28.02 grams of nitrogen. 1 mole of ammonia equals 17.047 excuse me, 17.04 grams of ammonia. And these vertical lines need to line up. Given 45.70 grams of nitrogen multiplied by 1 mole. Okay, so for some reason this 2 is missing. It needs to be there. Oh, dang. I sort of hate Word. All right, here we go. We'll put that as a subscript. Given 45.0 grams of nitrogen multiplied by 1 mole of nitrogen per 28.02 grams of nitrogen equals 1.631 moles of nitrogen. Okay, I'm going to move this so these vertical lines are above and below one another. 1.631 moles of nitrogen multiplied by 2 moles of ammonia per 1 mole of nitrogen equals 3.262 moles of ammonia. I'm kind of getting distracted here. Did I say, so 2 moles of ammonia per 1 mole of nitrogen. All right, we've got to move this over. Got to be 3.262 moles of ammonia multiplied by 17.04 grams of ammonia per 1 mole of ammonia equals 55.58 grams of ammonia. Given 125 grams of C2H6 and 225 grams of oxygen, determine the limiting reactant and the maximum mass of water that can form. 2 moles of C2H6 gaseous plus 7 moles of oxygen gaseous goes to 4 moles of carbon dioxide gaseous plus 6 moles of water gaseous. 1 mole of C2H6 equals 30.08 grams of C2H6. 1 mole of oxygen equals 32.00 grams of oxygen. 1 mole of water equals 18.02 grams of water. Okay, gotta move this over. 125 grams of C2H6 multiplied by 1 mole C2H6 divided by 30.08 grams of C2H6 equals 4.156 moles of C2H6. 225 grams of oxygen multiplied by 1 mole of oxygen per 32 grams of oxygen equals 7.031 moles of oxygen. 1.156 moles of C2H6 multiplied by 6 moles of water per 2 moles of C2H6 equals 12.468 moles of water predicted. 7.031 moles of oxygen multiplied by 6 moles of water per 7 moles of oxygen equals 6.0266 moles of water predicted. 6.0622 moles of water multiplied by 18.02 grams of water per 1 mole of water equals 109 grams of water. Amount of product recovered divided by theoretical yield times 100% equals 89.5 grams of water per 109 grams of water times 100% equals 82.1%. Reaction types. I found this error here. There's not a subscript of 3. There needs to be a subscript of 3 here. 4 moles of solid iron reacts with 3 moles of gaseous oxygen to form 2 moles of iron 3 oxide. 1 mole of gaseous iodine reacts with 1 mole of gaseous bromine to form 2 moles of gaseous iodine monobromide. 1 mole of gaseous nitrogen reacts with 3 moles of gaseous hydrogen to form 2 moles of gaseous ammonia. 1 mole of gaseous sulfur trioxide reacts with 3 moles of gaseous water to form 2 moles of aqueous sulfuric acid. 1 mole of solid calcium carbonate decomposes to form 1 mole of solid calcium oxide plus 1 mole of gaseous carbon dioxide. 2 moles of solid silver chloride decompose to form 2 moles of solid silver plus 1 mole of gaseous chlorine. Okay, 2 moles of solid magnesium oxide decompose to form 2 moles of solid magnesium plus 1 mole of gaseous oxygen. 2 moles of solid sodium react with 2 moles of liquid water to form 2 moles of aqueous sodium hydroxide plus 1 mole of gaseous hydrogen. 1 mole of solid copper reacts with 2 moles of aqueous silver nitrate to form 2 moles of solid silver plus 1 mole of copper 2 nitrate, aqueous. Well, let's go ahead. 1 mole of aqueous copper 2 nitrate. 1 mole of solid magnesium reacts with 1 mole of aqueous nickel 2 sulfate to form 1 mole of solid nickel plus 1 mole of aqueous magnesium sulfate. Okay, this is wrong here, it's magnesium. Okay, let's see. 2 moles of aqueous sodium chloride react with 1 mole of aqueous lead 2 nitrate to form 1 mole of solid lead 2 chloride plus 2 moles of aqueous sodium nitrate. Okay. 1 mole of aqueous sodium hydroxide reacts with 1 mole of aqueous hydrochloric acid to form 1 mole of liquid water plus 1 mole of aqueous sodium chloride. 1 mole of aqueous potassium carbonate reacts with 2 moles of aqueous hydrobromic acid to form 1 mole of liquid water. There's a solid here in the transcript, so that needs to be changed to an L in parentheses. 1 mole of liquid water plus 1 mole of gaseous carbon dioxide plus 2 moles of aqueous potassium bromide. 1 mole of gaseous methane reacts with 2 moles of gaseous oxygen to form 1 mole of carbon dioxide gas plus 2 moles of gaseous water or steam plus heat.